Hello, this video is section 5.3 in the Larson book, The Normal Distribution Finding Values. Now in the last section we had an x value and first we had z, then we had x when we were doing the application problems, and we were trying to find the area to the left, right, middle, and that was coming up with our probability of a random variable in a normal distribution being less than, greater than, or between two numbers. Here it's going to be kind of a reverse process of that. We're going to have the area, but then we're going to find the value for z first, then x, that produces that area. So it's kind of a reverse thing. So, alrighty, so we'll look at these two questions, and I'll look at this part down here. We're going to find a z-score who has 59.10% of its distribution area to the left, and then the next one will be z-score that has a 96.16 distribution of area to its right. Now we're going to use a function in the calculator and of course Excel. The calculator function is called inverse norm. You'll see it's located right below the normal CDF that we've used. It's going to be under second vars, which brings up distribution. So you're going to see that here in a minute. So the inverse norm works in a way that if you put in the area, it'll tell you, it'll assume that the area is to the left. Now it depends on what kind of calculator, the TI versions you're using. There is actually the newer versions, you can actually choose left, right, or center, but that's not necessarily needed. Maybe I'll do one where it goes the other way just to show you. But if you're having one that just brings up, some of them may just have the area of 0 and 1 and not have the left. You don't even have to have the with the 0 and the 1, because if there's no other numbers there, it assumes it's 0 and 1, meaning assumes it's a standard normal distribution. When we do problems that involve with a mean and standard deviation or something else, we will have to enter those values in. So you see these answers are yielding the same result. And then I mentioned here, if you're going to do area right and it doesn't have the thing that says right there, it would, which the calculator I'm using on this computer doesn't have the newer operating system where it gives you that option. So, but anyway, but you can always keep it as left, but you just have to use 1 minus the area to the right. Will tell you, and I'll show you'll see that one with an example too here in a minute. And on Excel, we'll change this to, we will. All right. Norm.s INV, and then when we're finding the x values here in a little bit, we'll use norm.v. So just like the last section, the TI only uses one function. It's just how much stuff you enter into it. Excel uses two completely different functions to do it. Okay. So for this one, and of course, even if I don't show every command here in the lecture, you'll certainly see them used in doing homework problems, but obviously I'll do some as we go. So this one, you tell it the area. Here's the calculator, so you go inverse norm, and I'll do it, and we'll see whatever choices this gives us. It's second, and then hit that vars button, which brings up the distr. Inverse norm, so you see it has the 0 and the 1 there, which we'll just leave. And our area to the left is 0.59. Like I said, I don't have to put the 0, but I will. Like so. And I think I'll maybe snip this out real quick. So put this in there. I'll rearrange all this later. like I said, it's going to be a little different entry. If you have the newer one, it's going to show the 0, the 1, and whether you want left, right, or center. Without the left, right, or center, it is always assumed to be left. And then I hit enter. Enter. There it is, 2, 3, 0, 1. So the Z basically is usually only used with 2 decimal places. I don't know, maybe the homework will ask differently, but it's usually only 2. A test question would probably only be 2, but rounding that to 2 is no issue. Move that out of the way. Then Excel. I think I got a worksheet open here. Yeah, so there's, in fact, I keep forgetting, okay, it's over here. I'll put in 5910. And there it is, 2301. All right, there we go. Now the next one, for the area right, you, in the calculator, now if you have the option where it asks you left, right, or center, I can't show you that from this calculator I'm using right now, but if it shows you that, you could actually put the 96, so we're looking for the value Z here where 96.16% is to the right of that, which is the green area. You could actually put 0.9616 and then just make sure you choose the one that says right there. Most of the things we're going to be doing, you'll see here in a minute, involving percentiles, everything's going to be left for the most part anyway. So after we look at these examples, and like I said, we may see this in the homework, pretty much all the application problems are going to be to the left. So, but you could do it as 9616 and put in right. What I did is I got the area to the left of that, which would be 1 minus that, so that we know there's 0.0384 to the left. Now notice I could have done that right here when I did it, but notice in the inverse norm, you don't have to actually figure out the number first here. You can just put in 1 minus 0.9616. You don't have to get it in advance because it will know, but you can either way. And then norm inverse, you do the same thing. Norm S dot inverse, excuse me, because 1 minus is what gives you area to the right. So I believe I had that. That's the one I had in there and I erased. So 1 minus 0.96. Here we have negative 1.77. There we go. All right. Now finding a z-score given a percentile. All right. Now by definition, percentile it always means the proportion of values that are below your percentile automatically. There's no such thing as if you said 85th percentile, there's no way that, you know, you look at it as, it would be 15% greater than that, but the term area always means to the left. So what I was saying a minute ago, that's why I'm about this section, mostly the values are going to be found, everything's going to be to the left anyway, so you don't really have to worry about that left, right, center feature. In Excel, if the calculator, whether you have it or don't have it, it's not important. So we'll use norm.s inverse in Excel or inverse norm. So it always means left percentile. So I don't have to tell you anything, you know, that's by definition. The examples on the other page, I had to clarify left or right, but percentile, not at all. And the normal way it's kind of written there is it's written as a subscript. So P sub 35 means 35th percentile. So P sub 38 would mean 38th percentile, and I just kind of drew a picture of the shading, what the area would look like. But calculator, no problem. You just do inverse norm and put in 0.38, and there's your 0 and your 1, hit enter, there you have it. So it's about negative 0.31 if it's rounded to 2 decimal places. Here it is in the newer calculator. It doesn't matter that the left is there or not. In fact, really, the 0 and the 1 don't even have to be there. So if you're using a TI-83, it's not necessary. Hopefully you aren't using a TI-83 just because of some stuff we're going to do later. And that's why I'm going to provide there's already by now there'll be a link in the learning management system about downloading a calculator you can use online or whatever, so like a simulator. Anyway, so hopefully the 83 is not going to be an issue. Oh yeah, now you see with the left, center, and the right, so it's just left automatically. And norm.s.inverse 0.38, there it is. All right. So same thing here, 72nd percentile, 72% to the left. Norm.s inverse 0.72 gives it to you. 0.72 for inverse norm. There we go, kind of all the same thing. 0.58. All right, so now transforming a z-score to an x value. So this is your formula over here that I know using the technology we haven't had to use this formula too much, but it's the value, and we did use it in the first unit though, x minus the mean divided by standard deviation. Now solving that formula algebraically to get x, it comes up to look like this. X equals your mean plus your z value times the standard deviation. So if the problem, like this first example, if it gives you the z value, you plug it right in, you're good to go. You're going to have the mean and standard deviation, but whenever it's a percentile question, it would need to have the percentile value converted over to z, then plugged in, which is not difficult either. Of course, then using technology, we're not even going to have to do that, but I just wanted to mention it to you. I probably have some worked out problems where it does show, or maybe I got rid of the manual calculations, I don't know, since you don't really have to use it. But anyway, yeah, I probably got rid of them. So this tells you the mean is 67, standard deviation is 4. And it wants to know what are the speed someone is driving based on these z-scores, 3 different ones. So these are your z-scores already given. So for 1.96, you just plug it right into the formula right here. So 67 plus 1.96 times 4 is 74.84 miles per hour. So that's 1.96 is basically 2 standard deviations above the mean. Now negative 2.33, so 67 plus negative 2.33 times 4 is 57.68 miles per hour. So if you're traveling 2.33 standard deviations below the mean, please stay in the right lane and out of the traffic. And then 0 will end up, yeah, if your z value is 0, you end up with just getting the mean, but 67 plus 0 times 4. All right. Let's look at this example. Okay. In a survey of men in the U.S. ages 20 to 29, the mean height was 69.6 inches with a standard deviation of 3 inches. Assume the data is normally distributed. What height represents the 80th percentile? Okay. So we're essentially trying to find this value over here where 80% of the values would be left of it. Now the technology we use is based on this formula, but I will mention that what you're actually doing, if we were doing it, you have the mean and standard deviation, and all you need is the z-score by doing the inverse norm or the norm S inverse of the 0.8, and you could plug it in there and then just use a regular calculator and figure that out. It wouldn't be that bad to do it that way, but since we have the technology to do it a little bit quicker, we might as well. Now in the calculator, The only difference is now, we don't use 0 and 1. It's 0 and 1 if we're just only trying to find the z-score. But if we're trying to find an x value, we need to put in the appropriate mean and standard deviation that goes with your problem. And I'll do it in this uglier looking calculator, I guess, for lack of a better term. Yeah, this is an example of one of the kind of the free download thing you can use from Wabbit.emu. But yeah, it does not. The other one is one that's with my work computer. I would have to pay for that software to be able to use it. So anyway, so there's inverse norm. The area, that's the percentile, it's 0.8, 69.6, and 3. So 72.12. So basically what the calculator did, what I was just saying, is it did the z value. It got the inverse norm for the z value, and then used that formula basically and converted it and got my x value. So we just saved a step there. So there it is. Norm dot inverse. You just so instead of just putting, here's where you use norm inverse. You don't use norm dot s dot inverse. You have to use norm inverse. All right, I'll do a different one. So it was norm inverse. The area was 0.8. Then it wants the mean. Then it wants standard deviation. There it is. Excellent. So the conclusion is we're saying that in that age group, 80% of the males have a height of less than 72.12 inches. Now, this might be a little tricky when you first see it, but now once I explain it, it'll no longer be tricky again. I think there's one in the homework like this. Now, what height represents the first quartile? Now, when we had discrete data earlier in the course, we handled quartiles in a manner where we talked about that Excel wasn't very good or consistent, but the calculator worked, or you could do them manually by finding medians. That's for discrete data, individual values. For continuous, the way you do this is you just treat. See, there's no values to line up. In other words, you couldn't do that. There's no numbers to enter because it's continuous distribution. So you just treat the first quartile as the 25th percentile. Oh, okay. So that's all we do. Yeah. So if it was third quartile, well, second quartile is just going to be the median. When I'm not going to ask that, but I could ask the third quartile, and you just treat that as the 75th percentile in this. So it's not the way we did quartiles for that type of data. So here it's just the same inverse norm command here. In fact, I could just type over this command and go over here and make sure I insert. I'll put a 0.2, then got to insert so I can add another number. Second insert 5. There we go, 67.576. And same thing with norm inverse. That one, just change that to I have the worst habit of doing that, and I can't break myself of doing that. Whenever I put this formula text command for you to see, which I think is wonderful, but I start trying to edit formulas right there, but actually the formula's in the cell next to it. I mean, you don't have to be, when you're doing problems, you don't have to be, unless you just want to display it for yourself. But my instinct, I always want to go to where I see the text, and I want to start changing the numbers there. But no, the numbers you change are actually right here. And even though I know not to do that, I continue to do it, and I'll probably keep doing it I wish I could break myself out of that habit. But anyway, there we go. So now we're saying 25% of the males have a height of less than 67.59 inches. Okay. Now, suppose Geddy Lee was told that his score in accounting exam was the 90th percentile, meaning he did better than 90% of the people that took the test. The exam scores are normally distributed with mean 72 and standard deviation 12. What was Geddy's score? We'll say rounded to 1 decimal place. All right, that's pretty straightforward. Just mean 90th percentile. So in the calculator, you would just do inverse norm, 0.90. Mean of 72, standard deviation 12. There's the answer, and there it is. There it is. See, with the left, it's the same thing. And norm dot inverse, 0.9 for the percentile. Mean 72, standard deviation 12, 87.4. Wonderful. Annual per capita consumption of ice cream in pounds in the U.S. can be approximated by normal distribution with mean 15.4 and standard deviation of 2.5. All right, the wording's a little different here on this, but once I explain to you how the wording translates to percentile, it'll be that way every time, so I think you'll be in good shape. What is the smallest amount of consumption that would put you in the top 25%? So you're looking for the cutoff value that just gets you into the 25%. And there's still 25% of people that are more than that, but what gets you right into that 25%? So let's look at let me explain the graph here, and then once you understand how this becomes a percentile, then it's super easy because we just put it in the calculator the same way we've been or Excel, same way we've been doing it. So this cutoff value right here, I think I'll get rid of that. That's not the actual answer to the question. That's just the z-score. I'll get rid of that. All right. So it's right here where that red line is. The red line, you want to know what gets you the point if 25% are above you. Well, if 25% are above you, that means 75% are below you. So this wording, the smallest of the top whatever percent, always means percentile will be 100 minus that number. So it translates to 75th percentile. So there you go. Then once you have it, you put in 75, 15.75, 15.4, 2.5. You don't need the left. There it is, 17.086. Norm inverse, 0.75, 15.4, 2.5. All right, so let's look at Part B. Part B says, what is the largest amount of ice cream that puts you in the bottom 15%? All right, the largest of the bottom. So we're looking for the cutoff that you're in the bottom 15%, but you're at the top of that 15%. You're the top of the bottom 15%. Right here, that cutoff line. Well, that wording means if you're at the top of that 15% group, 15% then are below you. So, long story short, that puts you in the 15th percentile. So you're the 15th percentile. So that means that wording, when it's worded like that, that means the percent that's given right here, that will be the percentile. Then once you know that's the percentile, it's super easy from there. 0.15, 15.4, 2.5, there you have it, 12.8. And norm dot inverse, 0.15, 15.4, 2.5 gives us 12.8 again. Wonderful. Okay, let's take a look at this one. The weights of bags of baby carrots are normally distributed with a mean of 32 ounces, standard deviation of 0.36 ounces. Bags in the upper 4% are too heavy and need to be repackaged. What is the most a bag of carrots can weigh and not need to be repackaged? not only from a business standpoint, and not only they may be considered to be too heavy, but you also may not want to be giving away too many extra carrots, I guess. So it's probably as much of a business decision there as anything. I don't think the bag is going to blow up if it's that, but anyway, it's not going to be that heavy. But anyway, still. So we're going to say if probably go through a weight scale there, trips, maybe it trips some sort of buzzer or bell, and, so somebody will take that bag off. They probably go take it back and open up the carrot bag and dump it back into with the other carrots. I don't know. I'm purely speculating, but at least that sort of makes sense. All right. So we want to find the cutoff for the upper 4%. So anything in the upper 4%, that cutoff value means the upper 4% means 96% are below that. So that's what the percentile is, 96%. We want the number that translates to the weight that gives us the 96th percentile, because we know that's the maximum weight, because anything more than that puts you in that top 4%, which we don't want. So once again, once you establish this is 96th percentile, it's super easy from there. 0.96. 32 is the mean, standard deviation is 0.36, there you go. And then norm dot inverse, 0.96, 32, 0.36. And there you have it. So 32.63 ounces is the cutoff, because anything more than that gets you right up into that top 4% that we don't want. Alrighty, average time a person spends on social media per day is 49 minutes. Assume the standard deviation is 16 minutes and the times are normally distributed. What is the minimum amount of time spent on social media to qualify for the top 10%? Sort of like the carrot example. Top 10% means that there's 90% below that. So that's what you have to establish, that the top 10% means 90th percentile. I just put the formula there, even though we're not using it, just to remind you of what's being calculated. So once you know it's 90%, it's easy. You just put in 0.9, 49, 16, and you get 69.5 roughly. And as I mentioned before, a lot of these times it says 69.48. This is probably from someone that, for these are a lot of test banks and questions still based on people using the old way of doing it with a chart. Anyway, long story short, the Z would have been rounded to 2 decimal places instead of the technology using more than that. So rounding it, if somebody did, like if you did the inverse norm, for example, and I think I might show you that here just for the heck of it, and use 2 decimal places, it probably will generate that answer. But anyway, let me finish what I'm saying here. And then norm dot inverse 49, 16, or 69.50. Yeah, this won't take but a second. So let me show you this. I won't do it both ways. I'll just do it one way. But I'll go second inverse norm. And then 0.9, and now I want this to be 0 and 1. So let's say I round that to 1.28. So if I use this formula, it'll be the mean, 49, plus 1.28 times 16. Yeah, see that? 69.48. So that's what it's doing. If someone would have used the chart to get it, they would have found 1.28. And that makes the answer slightly off. But you just pick the closest answer. Notice none of them are really close. Oh, I want to show you this real quick too. You do have to do it. It won't matter if you do it correctly, you'll be able to get to the right answer. But I'm going to show you, what if you misinterpreted this? I'm not saying every question would be this way, but this one is. I'm going to show you. Let's say you put 0.1, meaning you treated this as a 10th percentile. Of course, technically, if you had the fancier calculator, you know, and it has the left, right, you could do to the right, but I never wanted to bother to get into that. Why show something that was completely unnecessary? But look at that answer, 29.5. Oh, I thought, wait. Oh, 28.5, excuse me. Yeah, you see, if someone had misinterpreted this as meaning that was the 10th percentile, they would have got answer C. So if you do it correctly and it's a little off, that's going to be okay. But if you completely misinterpret the concept, then you may stumble into the wrong answer that way. So, well, that concludes the lecture portion of the show here. All right, it's homework time for this section. So let's see what we have here. We have graph, area to the right. Now, of course, percentile always means area to the left. So the commands that we use, the calculator, we would have to treat this as 1 minus that number. That will be the area to the left. And you don't have to figure out that number in advance because you can just enter it in there as 1 minus. And I'll show you. It'd be what, like 9633 if you did figure it out. But you don't have to by either method calculator or Excel. Okay. And so let's see what we got here. Inverse norm. Area, so you'll put it right there as 1 minus, I think it's 367, yeah, 0.0367. 0.0367. Yeah, so it'll take care of it for you right there. We're finding a z-score, so it's 0, 1, paste, and that will be the z-score. And same thing here in the calculator. I already have these functions sitting here, so I'll just go right to this command and put in 1 minus. Zero. All right. And there we have it, 1.79. Well, let's just see how many decimal places at once. 1.79, which is what I would have expected for a z-score. Normal probabilities 4 decimal places is the standard, and for z-scores it's just 2. But, you know, you never know, so always do whatever it tells you to. Bingo, we got it. So now we're trying to find values, now x values. All right, so let's see what we have here. The mean weight is 158.8, standard deviation 47.4. It wants 98th percentile. So this will be 0.98. Mean is 158.8. Standard deviation of 47.4. And one thing I want to mention that I didn't mention in the last section, I forgot, in case anybody's using like a TI-83 or an older operating version of this, it won't put out this nice and pretty little where it shows you everything. If you do inverse norm, it'll just bring up inverse norm. Well, let me hit enter here and I'll show you. You can't, let me go over, and you just have to enter the numbers yourself in this order right here. So you'd put in 0.98, comma,
because the older calculators will just give you inverse norm, probably has the left parentheses there waiting for you. So then you put in the mean, comma, standard deviation, comma, and then there. That's what. So it won't have the nice, pretty entry there or whatever, but that's how you do it. So in fact, that's what. So the calculator's showing you that whenever after you ran it in there. So it wants 1 decimal place. So let's make sure the Excel matches. All right. So it'll be this one, the norm inverse. Norm S always means standard normal distribution for either one of these. Mean 0, standard deviation 1. The other one means you have to put in whatever mean and standard deviation it is. So this area was what, 0.98? And I think it was 158.8. I'll double check that before I hit enter. I want to say 47.6. I don't know. I'm going to look to make sure. I don't want to trust my memory here. I said 158.8, but I typed in 158.6, and it was 47.4, so I was definitely wrong with what I said there. 158.8. I thought that's what I said. Maybe I didn't. I don't know. It doesn't matter what I said. There we go. Well, that looks pretty good compared to the calculator answer. And it wanted 1 decimal place, so I like 256.1. Excellent. 42nd percentile. These will be kind of quick, because we have the same info. So really, I can do inverse norm again, or I can go second, enter, and it brings back your last command. Then all I got to do is go back and change that from 0.98 to 0.42. Because we're using the same mean and standard deviation. Obviously, if I had to change the mean and standard deviation, it'd probably be easier just to type it back in from the beginning. So 149.2, let's see what our calculator says here. Change that to 0.42. $149.2. Third quartile. Okay, quartile, it's not quartiles. Well, it kind of means the same thing, but the way we handle this is not like we did just quartiles with discrete data where you have all the numbers and you break them down into quarters. This one, you just treat the third quartile as the 75th percentile. That's exactly how we need to do it here. So knowing that, that'll make this not too bad, because I can go second enter again, change that area at the very beginning to now 0.75. All right, and hit enter. Let's see what we got here. Excel. Okay, just change that to 0.75. Got a match. 190.8 I like as a rounded answer. Look at us go. There's one I definitely want to do. This one's interesting, so is the next one. This one has a lot of parts to it. Let's see. I think what I'm going to do is I'm going to do the next one, but I'm going to tell you verbally what's happening here, because this is I did this kind of an example on my notes, not with pregnancy links. There was something else. I think one of them was about ice cream consumption or something. And but if you go back, and that will verify what I'm about to say right here. So this one says 9%. So if it says top 9%, that means bottom 91%, and bottom is what your percentile is. So top 9% means just do this problem as a 91 percentile. Now the next one, because it says bottom, that's your percentile. So part B will be a third percentile. 0.03 will be your area. So 0.91 for that one and 0.03. Of course, your numbers may change. I'm going to move forward and go back and just to see if they changed. Yeah. So this one would be 88 and that one would be 5. All right, I think you can handle that. I have confidence in you. I'm going to work this one out. All right, this is just a probability question, first of all. So we go back from this chapter, the previous section, basically. Part 2, normal distribution, part 2. And below 85, that'll be less than. So I'll do calculator. And I'll go second, distribution, normal CDF. And that's the lower already there for me, so we got that. 85 goes right here. 73 is the mean. 7 is the standard deviation. Let's see what we get here. All righty, let's see if this matches. It'll be this command up here. And I know we got a 73 and a 7. I need to double check the first number. Nope. 73, 7. And the less than was 80 something, was it? 85, okay. I would have said 86 and I would have been wrong. I like it, 95676, so it's probably going to want 4 decimal places, so let's go 9568. Wonderful. Okay, another probability question. I'm sure there's a percentile question coming up here somewhere. Between 66 and 93. But this doesn't hurt to see this again. Let's see, 66 and 93. Actually, I can do well, actually, I'll tell you what, I'll just enter them in there. I was going to do a second enter, but we're already going to have the mean and standard deviation in there anyway, so 66 and then 93. And then here's how you do the betweens. 93 would go first. The large one always goes first. And if you got them backwards, you get a negative number. And probability cannot be negative. Actually, it would just be it would be the positive of that number. I'm not sure if Excel would give it as a negative number or would give an error. Might give it as negative. Probably give it as negative. And then 73 and 7. But the final answer can never be negative. Right. Let's see. Oh, not 173. I got an extra 1 in there I don't need. That looks all right. And it's not. Which one is wrong here? 66 to 93. Oh, 66 and 9. Maybe the calculator's wrong. 73 and 7. Let me check that. Could have had a typo on the calculator. 93, 73, 7. Huh, I wonder what I had wrong. Okay, there it is. 8392. Strange. I didn't change anything. Oh well. Eight three nine two. Excellent. Wording on this one's a little bit weird. I wouldn't really ask this kind of wording on a test. I like the top and bottom wording better, but probability that a student taking the test scores higher, 15%, that they score higher than what grade? That means the upper 15%. So the probability is 15% you do better than a certain grade. So that's a fancy way of just saying the top 15%. Yeah, that's all right though. I'm glad I did this one for homework purposes, so hopefully it won't give you too much grief there. This will be inverse norm value. Be 0.85, 73 and 7. All right, so let's see what a calculator it says. What's it want? Nearest integer. Okay. Well, I guess for test score that makes sense. They'd want the answer as an integer, but let's make sure I'm not putting it in there until we see it in Excel. So this bottom one, 0.85 and 73 and 7. $80.25 wants nearest integer. Well, I'm going to go with 80. Love it. All right. This one, basically we can just calculate z-scores on this one and not have to worry too much about specifics. So it says 80 on the exam, mean of 73, standard deviation of 7. So let's come back over to the calculator. I won't bother. This doesn't require any Excel use here. This is just a calculator thing. Now you can use Excel as your calculator, of course, but I don't need to show this both ways. Oh, because all I'm doing is arithmetic here. So I don't want to waste your time doing that. Well, if I could type this in there properly. Good grief. What's the matter with me? I can operate a handheld calculator better than I can. It's tough sometimes punching these things. Standard deviation of 1. And what's the other one? 70 on an exam where the mean is 64 and standard deviation is 3. Two, that's a better standard deviation. So technically, I don't really see this anywhere too much, but it's possible. I don't know, maybe like something that's really, really hard, like med school engineering or something where you're trying to be your grades based on your percentage ranking, not normal where 90 and above is an A. So long story short, in that case, the second one's better because you're more standard deviations above the mean, which then gives you a higher chance to be in an upper grade level. Let's see. So let's see how they're going to want us to answer this. Better off with a grade of 80? Worse off. Because the z-value for the grade of 80 is 1, and the grade on a different exam is 2. Wonderful. And that will conclude section 6.2, normal distribution part 3.